Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T. In this video, I'll be sharing the solutions to your Conics Translations Part 2 assignment. I'm away, so I wanted to share the solution so you can check how you did. In this assignment, problem 2a, we have this conic to convert to standard form. Now we know since we have two letters squared with both the same sign and same number, this is a circle. So our first step is we want to regroup this, so we want to pull the x terms together, the y terms together, and any constant we want to move to the other side. In the grouping for the x's, we're going to complete the square. Since this y squared is standalone, we don't have to complete the square. And remember, we take the number in front of the x and take half of it, which would be 4, and square it, and whatever we add here, we have to add over here. This trinomial that we had just completed, we now factor and add these two numbers. So we have a circle with center at -4, 0, and our radius is square root of 20. Okay, another circle, so this is also a circle. Again, we want to group the x terms together, the y terms together, and take this constant to the other side. Since we have the 6y here and the 4x, we have to complete both squares. So here, half of that's 2 squared is 4, and 4. 3 squared, 9. Factor that as a perfect square. Factor that out to here, a perfect square. Add those, we get 16. So again, remember when we get the center, we're taking the opposite of those two numbers. And the square root, this is r squared, so we have to square root that to get r. And another circle. So this first batch are all circles, and the next batch we'll be looking at other conics. So again, we're going to group the x terms together, group the y terms together, leave space for completing the square. Move this over. Half of this is -5 squared is 25. 3 squared is 9. Add to both sides. That adds up to 0. And again, now we factor this. Since this is negative, this will be negative, positive, positive. And again, to get our center, we're taking the opposite of that number and the opposite of that number. And the square root of the 9 gives us our radius. So let's look at something that's a little bit more complicated. Let's look at this problem. Now we only have one letter squared, so we know it's a parabola. So we want to get all the letters for the squared part, meaning the y's, on our left, and everything else to the right. So I'm adding 2x here to both sides, and subtracting 94. Now I need to complete the square. And I'm taking half and squaring, so -10 squared is 100 to both sides. We're going to combine those like terms. On the trinomial side, we're going to factor that as a perfect square trinomial and combine here. And then we want to factor whatever number's in front of the x, so I'm factoring out a 2. So again, this was a parabola. It's horizontal, because the y is squared. My vertex, the x is the opposite of this, and the y is the opposite of that, and this is 4 times p, so p would be 1/2, and it's opening to the right, because p was positive. Okay, so let's look at I think this might be our last problem here. We've got two numbers that are the same sign and opposite signs. That makes it an ellipse. So we want to group the x squared stuff together. the y's together and move this to the other side. And we're going to do 2 completing the squares, but before we complete the square, we've got to factor out that 4. So I'm factoring a 4 out of those 2 terms. And I've got x squared minus 12x, and I'm leaving space to complete the square. Here there's a 1, so I don't have to do the factoring. Again, remember we take half of that number, and then we square it. Same over here. Now when I add over here, remember I've got to distribute that 4. So 4 times 36 is 144. Here 4, we're not distributing anything. And we factor our trinomial. Now this we said was an ellipse, so we want it equal to 1, so we divide everything by 100. Here we can simplify that, and we're getting the 25. There's nothing to simplify here. And again, this is our final answer. Again, that was an ellipse. It's the bigger numbers under the y, so it's a vertical ellipse. The center is at 6, 2. Our a is 10, because that's the a squared. Our b is 5. And again, we could use, I'm not going to go through that, but we could use c squared equals a squared minus b squared to determine our distance to the foci. And when we measure these distances to the vertices and co-vertices, it's relative to that point. And I think that's how it was our, oops, sorry, there was one more problem. We have a hyperbola here. Again, group the x squareds together, or not the x squared, but the x terms, and our y terms. This minus goes with that. Move this to the other side. Now I've got a GCF factor of 9 and a negative 1, so that we have the x squared and y squared standalone. So I've GCF factored and left room for my completing the square. Remember, when I GCF factor out a negative, this is going to become the opposite sign. Add my terms, remembering to distribute my number out front when I add to the other side. We have to divide by here, because we want that equal to 1. Here that cancels. And again, we have a hyperbola. This would be a horizontal hyperbola. Our center is at 4, 4. Our A is 1, and our B is 3. So best of luck with doing your conversion from quadratic form to standard form.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you